Okay, this is a supplemental lecture on the UNIX find command. Basically, what the find command does is it walks a file hierarchy, which is the definition that's given in the UNIX man page. But another way to explain it is it searches a file system for file system objects based on certain criteria. Now, the syntax is you have the find command, then you have options, then you have a path, which is where you want to start in the file system and traverse downwards through all the subdirectories and look at all the files and folders. And then you have an expression that tells what you're looking for and or what's supposed to happen when you find a file system object that meets the given criteria. Now, find has 30 options and over 50 what are called primitives. And primitives are basically the things you are checking for. And I think the easiest way to explain this is just show you some examples and talk through what those examples are doing. So the first example is this. So I want to start at tilde Wayne. We've talked about how that is an relative file name and tilde is a special case. So tilde user ID means start at that person's home directory. So it would start wherever my home directory was on the system. And I want to examine file system objects based on their name. And I want them to end in .pl. So I'm looking for Perl programs. I have to put a backslash in front of the star so that the wildcard is not expanded, so that it's actually passed into the find command. And then for every file system object that matches that name, I would like to print it out. So when I run this command on my laptop, this is what I get. So I get over 900 files. So I've over the years written evidently lots of Perl programs, but it's just going to go through and list out the Perl programs as it finds them. This is the next example. This is something I actually did when I was trying to prepare one of your previous homeworks. I was looking for a particular graph of a particular month of web statistics, and it's been a while since I looked at it and I couldn't remember where I stored it. So I said starting at the root directory, which is slash, so at the very top level of the file system hierarchy, look for any file that has web stats in its name and print it out. So I ran that command and it came up and said on my laptop, this is where it is located. So it looks like it was stored in AWS in Glacier. So I looked on another machine and actually found it elsewhere. But that is the command I issued. Another example is this. Now, one thing to talk about before we talk about the actual find command is the semicolons. In Unix, you can put multiple commands on a single command line as long as you separate them by semicolons. So what this says is tell me what the current date is, then issue the find command, and then give me the date after that. So what I'm trying to do is figure out how long this find command will take. So I'm saying find slash, so I don't give it any criteria, so it will match everything, and then I want to pipe that to the word count command to tell me how many lines there are. So this will basically tell me how many file system objects there are on my laptop. And when I ran that, this is the output I got. So you'll see it took about 13 minutes to go through the whole process and tell me that there are 20 million files on my laptop. In this example, I am wanting to look for web server directories or files, and sometimes they're called HTTPD, other times it runs as Apache. So I'm not really sure which. So my criteria is the name either has HTTPD in it, the -O is, or the name has Apache in it. And then for any match, I want to print that out. The -xdev means don't cross devices or don't cross file systems. So if I have external hard drives mounted, NFS things mounted, I don't want to traverse down into those. I want it to stay on my laptop on the main drive. So that is an example. And this is the output that I got. It took about 8 minutes to run. And it told me here are some Apache things on the system. But even Apache uses httd.conf as its configuration file. So these are the files related to the web server on my laptop. In this example, I am looking for a known bad directory name or file name .gof. On Unix, any file name that starts with a period is considered hidden. And to actually see those, you have to use the -A option, for example, on LS, to show all files, including hidden files. So I suspect I have been attacked, and I'm looking for a directory. So that's what the -type D is. And the directory name I'm looking for is .gof. And I want to print that out. Now, a lot of times when you do this, especially if you're running it as a user account, you will get a lot of permission not found. So the two greater than means I want to redirect standard error, and I want to send it to dev null. Dev null is basically throw it away. So it's the device that'll just take stuff and do nothing with it, or produce, if used as input, an infinite string of null characters. So when I run this command, it took 12 minutes about to search my whole machine, and it actually did find a directory named .gof that was located in /temp. So a couple of new things there. Now, I'm going to do a little sidebar about redirecting standard out. Basically, we've talked about how standard out is wherever error and or warning messages are going. Redirection of standard out depends on what shell you're using. So, kind of a sidebar within a sidebar. Unix has a number of shells. The first shell ever created was sh, or /bin/sh sometimes is how it's referred to. And it was called the Bourne shell, Bourne, because the person who created it, his last name was Bourne. And that was the shell we had forever in Unix, starting in 1969. Well, at some point, Shell has its own programming syntax and language built into it, and most of the people on Unix at the time were C programmers. And somebody said, gee, it's kind of a pain that we program in C, but when we want to program with bin sh, we have to do it in a different language. So at that point, the C shell was created, CSH. And its syntax when you're programming at the command line is more similar to the C programming language than the syntax in bin sh. So, and there's a ton of slews of shells. There's TC shell, there's Z shell. One of my favorites, like I said over and over, Unix is a play on words. Bash was a rewriting of the SH shell. And again, it was written by somebody whose last name was Bourne. So Bash is a shell, and it is said to stand for the born again shell. So it's a redoing of bin sh and a play on words. So if you are using sh or one of its derivatives like bash, then you are just going to use the two greater than, which is really easy to do that, and what we saw in the example before. Now, if you're using C shell or one of its derivatives like TC shell, it's a little more of a pain. You can redirect them with greater than ampersand. Or if you just want to do a standard out, you can say, I have a command, I want to redirect standard out to output.txt, and I want to redirect standard error to dev null, which again, sending something to dev null is basically ignoring it or throwing it away. So back to the find command, another example. So here's a find command. I want to start at the top of the file system. I want to stay on that hard drive or that partition. And we have a new primitive -mtime. And mtime is for modified time. And you give a number after the -mtime primitive. If it's a number with no sign, that means exactly that many days ago. If you say minus and a number, like I've done here, it's within, in this case, the last day. And if you put a plus there, it means more than one day. So what I'm trying to do here is print out all the files on my laptop that have changed within the last day. And this is the output. There were 59,000 files that changed on my laptop in the last day, so that's quite a bit. But it will list out all the things. So if you think you were hacked within the last day, you might do this to look for things that have changed on your system in the last day. mtime is in days. Sometimes you want to be more granular than that. So most modern finds have -mmin. So it is basically modified time, but it's in minutes instead of days. So what this command does is it finds all the files that have changed within the last 30 minutes. And, I still got a lot, but not as many. When I ran this on my laptop, I got about 6,500 files that came out. And it took about 3 minutes to issue that command. In this example, I'm introducing the primitive -user, which can tell files owned by a user. So on my laptop, I have a presentation account that has a very minimal desktop, a very minimal dock, no files on the desktop, so that if I do a presentation, what I'm displaying to the audience or the class doesn't have a lot of stuff to distract people, and it looks nice. So I just used it and said, hey, show me all the files on my laptop that are owned by the user presentation. And when I ran that, I got 115 files. And here's the first few that are shown. And looks like it took about 14.5 minutes to search the whole system to find these files. Want to do a little sidebar on Unix permissions before we proceed on with some of the other primitives that we have with the find command. So in Unix, the concept of permissions is we have three groups of people for which permissions can be set: user, group, and everyone else, which is referred to as other. So the user is the user that owns the file. The group is the group that owns the file. And other, like I said, is everybody else. When we refer to these symbolically in commands, they're represented by lowercase u, g, and o, respectively. Now, within each of those groups, you have three primary permissions, which are read, write, and execute. They're represented as R, W, and X. So if we look at the output of the ls-l, which is a long listing for the current directory, I get this. So I want to concentrate on the first 10 characters on the output here, the dash, RW dash, R dash dash, R dash dash. So what that means or represents is the first character is the type of file system object it is. And the most common are shown here. If there's a dash there, it is a file. If it is a D there, then it is a directory. And then the remaining 9 characters are for the permissions. And what they represent is the following. The first 3 are user, the next 3 are group, and the last 3 are other. And then within each group, we have read, write, and execute. If that letter is shown there, we have that permission. If the letter is not shown, then we do not. So that is how Unix permissions are designed. Like I said, they're actually stored as 9 bits, not the 9 characters. And the presence of the bit means you have that permission. A 0 bit means that you do not. And when we refer to these permissions, we take each set of 3 binary bits and we represent it in octal, which is base 8. Because if you have 3 positions that have 2 possible values, the possible number combinations is 2 to the 3rd, which is 8. So a lot of times we do things in hexadecimal, but these are one of the things in Unix that are in base 8. And the reason that when I do bases, I have examples of base 8. So there is a -perm primitive that looks for files based on their permissions. If it is a number without a sign, for example, 644, then I am looking for a file whose permissions are exactly 644. If I'm using a minus sign, I'm basically using a mask, saying whatever bits I've shown here have to be set. So the first 0 is for user, the second 0 is for group, and the 2 is for other. So within other, there's read, write, and execute. And a 2 corresponds to having a 1 in the middle position, which would be write. So basically, I'm looking for files on my hard drive that are world writable. That means anybody on the system can write to this, which is typically a bad thing. So I ran that, and I got a handful of temporary files that I'm not showing, and it took 13 minutes to run through that. Now, for the files, if I wanted to correct those permissions, as well as use this as an opportunity to introduce a new primitive to you, I do the find command, I look for files that are world writable, I print them out, but then for each of those files, I want to execute a command. and that command is change mod other -w. And the curly brackets mean whatever file matched, put its name here. And then the exact command has to be terminated with a semicolon. And I just told you a moment ago that semicolon means I'm going to put another command here. So I have to escape that by putting a backslash in front of it to say, pass this semicolon into the find command. Do not try to use it as a special symbol on the UNIX command line. And when I do that, I get the same handful of temporary files shown, but it should change the permissions. That's what the change mod command does, or chmod, whichever you prefer calling it. So then I turn around and reran this command. And I did get a list of files, and then I realized that you have symbolic links, which we talked about when we talked about file systems. Symbolic links permissions are always 777. So if I wanted to rule those out, it says symlines. I guess autocorrect got me. It's supposed to be symlinks. I apologize for that. I would need to use the dash type flag to be a little more specific, but this, serves my case. So that's exactly what I did here. I wanted to find files and directories that had world writable permissions. So notice that I can put conditions within parentheses, but that I have to escape them so they're not interpreted by the UNIX shell. Between every single primitive is an implied AND. So if I did not put the parentheses there, it would have done the dash type D dash perm combined together instead of doing the OR for file or directory and then doing the permissions separately. And when I did that, I got no output because it did not look at symlinks, and I had corrected the permissions on all the files and directories with a previous command. Here, I'm looking for files based on their size. Size takes a number. Again, if it's an absolute number with no sign, it's going to be exactly that size. By default, if I don't give it a letter after the number, it's going to assume 512K blocks because that's what original Unix file systems were based on. So my dash size primitive with the +1G is saying look for files that are larger than 1 gigabyte in size and print them out. So when I issue this command, I got 107 files on my laptop. Shown are a few at the top, and it took about 7 minutes for this to run. So really large access log that we've used in class, a tar archive of my SWeb account, and then a virtual hard drive for VirtualBox of Kali Linux are the things that I actually included here, like I said, along with 107 other files. And that's the end of talking about the find command and giving you some examples.